All right. Well, we are going to be getting going here in just a couple of minutes. Yeah, just want to welcome Dan, Eric, Mike, Steph. Good to see you. For those of you who haven't done the happy hour before, we'll start in about 5 minutes. But if you do have questions, you can chat with us via GoToWebinar. Use the question box over at the top of your screen, and you can ask us questions there. We'll be answering those live as we go through today. And for the first time, we are actually going through and enabling YouTube chat. And that is because starting next episode, we are going to be streaming exclusively on YouTube, specifically because while GoToWebinar has been a great friend to us as we've done this happy hour in a smaller venue, as we do move to a larger audience and a greater circle of friends, we are going to be using YouTube because using the integration within GoToWebinar, the bitrate is not quite where we want it to be. It's really nice to have that convenient integration with GoToWebinar where you can stream to LinkedIn and you can stream to YouTube, but it's only giving us like 30 kilobits per second up out of that integration. So the quality, you may have noticed, hasn't been that good coming out of that. The bit rate's a bit low, so we will be streaming directly out of YouTube starting next episode, and that is August 7th. Looking
I'm
forward to that.
I'm looking forward to that because I'm watching the delay on YouTube right now, and it's terrible.
Oh yeah, exactly. There is a bit of a delay. It's like a good 15 to 20-second delay. So it makes it difficult because we could be like trying to answer your questions, and all of a sudden, oh, we've already moved on to a new topic, and oh, well, let's go back a little bit. And you've seen us do that a little bit. This week, we're actually not in our usual studio. We are on the road this week. I am down in Milpitas right now at our Northern California headquarters. As you can see, it is a beautiful day outside. I am here with our good friend, Mr. Evan Temudo, and he is one of our field service engineers and my partner in crime when it comes to working on training content.
Yes, sir.
Yeah, excited to have you here, man.
Yeah,
you've seen Evan in a lot of our Learning Lab videos. He's
Yeah.
a very familiar face.
Yeah.
Great to have you here, man.
Yeah, it's great to be here.
Yeah.
Thanks for having me.
Yeah.
Hey Evan,
And
what do you think of the setup right now for night mode? Like, do you have your beer ready? Do you have your frosty beverage ready?
we do have
Sure
frosty beverages, and it is we're getting towards that time. We've got just about a minute before we can crack this thing open. But
Whoops.
Love the setup.
Yep. Okay. Yeah, Jen wants to know what we're drinking, and yep, Tim is reminding us to make sure we actually tell them about the beer and if the beer is good. That is
Yes.
one thing that we have failed to do, and that is my fault. I am sorry. Again, we're going to be starting in just about 1 minute.
we have to do.
But,
we have to like set an alarm for the beer check-in. Like, how's that beer tasting for you?
It's a good idea. I'll set one on my phone.
But for those of you who are joining us, yes, we are going to be moving to YouTube for streaming purposes starting next week, August 7th. The GoTo integration, while it is convenient and has been good for the smaller happy hour that we've been doing since 2024 with our customers and friends out there in the industry, now that we've got a bigger circle of folks and we want a better bit rate, we're just going to go straight to YouTube and use YouTube chat. That may include the use of the band hammer. I actually have a band hammer that is in the other studio that we may start implementing starting next episode, but we just want to remind everybody to play nice. If you find that you cannot communicate with us or you can't type into chat, it's because you need to be a subscriber for at least 5 minutes, and that's just to deter a little bit of some of the potential trolling that I'm sure you've seen on multiple YouTube chats. So
But not
glad to have
our friends.
each and every one of you here.
Our friends
What's that,
wouldn't
Ken?
troll us. Our friends wouldn't
yeah.
troll us.
You gotta embrace it,
Yeah,
Can't get away
I don't
from
take it personally. I'm not the soft-hearted person I used to be as a much younger person.
Part of the
Can we
culture.
name the band hammer Mjolnir? Yes, we can. Absolutely, we must name it Mjolnir, or give it Mjolnir Edge or something silly SolarEdge themed.
Yeah, there you
Yeah. So let's go ahead and get this started. All right, ladies and gentlemen, how are you doing? My name is Chris.
My
This
name's
guy over
Cameron.
here is Cam, and this is Evan. And this is SolarEdge Night Mode, your after hours happy hour for solar enthusiasts and our friends out there in the solar world and the world at large. It's great to see each and every one of you. Eric, Dan, Mike, great to see you guys. Steph, Jen, great to see you as well. We've got folks that are joining us via GoTo as well as chat. So if you are joining us via GoTo, just use that question box. We'll be answering your questions live as we go through. Otherwise, if you are watching us on YouTube, you can use the chat to talk with us. If you're finding that you can't chat, you need to be a subscriber for at least 5 minutes before you can join in the chat. Other than that, next session we're doing is August 7th. We are going to be streaming exclusively on YouTube just to get the better bit rate. GoTo has been great, but we are moving to a different platform just to make this look a little bit better. Not that that's going to help much with this, but the bit rate in general and the sound quality will be better. So thank you for your feedback. We are more than happy to move over to YouTube and really happy to be on that platform. So
I gotta say,
we're gonna,
I see some of our usual suspects here, which is always nice. I'm glad they join us every couple of weeks when we do this. I see Annalisa in the chat, and I just want to say thank you for for coming and hanging out with us.
nice, huge. Oh, Jacoby, huge fan of stouts and DC coupling. You are going to be the best buddy of our good buddy. You're going to be a great buddy with him. He is a big fan of stouts. Um, I used to be, but now I've hopped on the IPA train and the ale train and the red ale train. So,
That's
yeah.
funny. Was it,
So that brings us to a very important question. Cam, what are you drinking today?
Well, you again, we're not in the studio. I'm in Southern California, and so I try to get some of the blue lights behind me so we can still have a little bit of the night mode feeling. But today I am drinking Cali Creamin'. It's a vanilla cream ale, and it's from Mother Earth Brew Company, and it is I've had it before. I'm not trying something new, but it is a wonderfully just very simple ale that has a nice little vanilla note to it, little caramely notes in it, and it's one of those things that I just want to put a scoop of ice cream in it, have a beer float. But it is fantastic. So cheers.
Excellent. I will crack mine open right now. Evan, what are you having?
Yeah. Well, I'm having a Japanese IPA, Kyoto IPA. So yesterday after sushi, we walked over to the Asian market, and this is one of the things they have. I'm a huge fan of IPAs. Really cold, crispy IPAs. The more it tastes like a bar soap, the better it is. So I'm excited to see how this is.
Yeah, we are in the Bay Area, so of course you have to take advantage of the fresh seafood while you are here. And of course, there was an Asian market right next to the sushi place we were at, so we both got Asian themed. I got Onibi, and this is a very nice California rice lager, and it's quite tasty, a little bit tart on the finish. I had one of these last night, and yeah, for those of you that don't know, California is one of the biggest producers of rice, and so happy to go with the Japanese theme here. So,
Yeah.
cheers, Cam.
Cheers.
Cheers.
Man, you guys are drinking straight out of the can? For shame.
I know I couldn't break into the marketing closet to get the SolarEdge themed pint glasses, unfortunately.
Couldn't or wouldn't?
Yeah, we have
I tried. I just couldn't get in.
Yeah, it's not the same.
Yeah.
So of course
if
we
you
always
are
have.
enjoying. Oh,
Yeah, sorry. Go ahead, Chris.
so of course, if you are enjoy responsibly. Normally, our wives would be picking us up after this session, but in this case, we're just walking across the street to the hotel, Evan and I, and Cam.
I'm just staying here.
Nice.
Cam's already there.
I'm already here. It's a long drive from Sacramento down to LA, so I'm just gonna let my wife.
That'd be a heck of a pickup.
Okay, so
All
what
right.
are we talking about today? We're doing design.
We are talking about solar system designs, Cam, and this is definitely in your wheelhouse because I share an office with you, so I know that this is a lot of the bread and butter and a lot of the stuff that you do on a daily basis.
Yeah, for sure.
So,
Absolutely.
I thought it would be best in this situation if we kind of broke it down between, the three primary systems that we see out there in the field and just talk about some of the design basics for each of them, starting with, the old tried and true since the 70s back in Grass Valley, homesteaders putting solar on their homes type systems, and that's string inverters.
Yeah,
And,
sure. Yeah, I'll
it's
just go from
changed a
there.
bit in the last few years.
A little bit. I'll say design has gotten much easier, and there's a lot more powerful tools available for system design. So back in the day when I used to do system design, so I've been in the industry for 21 years, and my first 7 years in the industry was installation and design and permit creation, plan creation. So design and engineering. But again, I'm not an engineer, so I don't call myself an engineer. So I digress. When I started, we always looked at the rooftop. We always looked at the rooftop, and we would determine how many modules can go on the rooftop. And then we would use whatever design tool the inverter manufacturer had. And in my case, it was like SMA, and they would say, okay, put in your module, put in your weather data, and here is how many modules you can put on a string. And it was limited by voltage. You're trying to hit the voltage MPPT window of that old school string inverter. And so, as we know, when modules are wired in series, voltage becomes additive, and the tool would spit out some number, usually between 6 and 9 modules. And the biggest pain in the butt is all of the modules had to be facing the same direction. They all had to be even string lengths. So it was a single MPPT inverter. So all your modules had to face the same direction, be the same string length. So if you wanted to do a string of 25 modules, if you wanted to do 25 modules on a system, you'd often have to get multiple inverters, or you'd have to maybe drop a module and do 4 strings of 6. And as modules got bigger, this became more difficult to do. So the biggest limitation when you start any system design is where are you putting it? Where is it going? Is it going on your roof? Is it going on the ground? What does your roof look like? The next thing you need to look at is what does the cold weather data tell you about module voltage? And
The
so you
dreaded
have
temperature
to,
coefficient calculation.
yeah, it's a really long equation. And I'm sure I can find it. I used to know it by heart. But it's basically, if you look at the back of every module spec sheet, it'll tell you some value for a temperature coefficient of voltage. And it'll say something in the wheelhouse of negative 0.026. And so that means a quarter of a percent. Your voltage will change a quarter of a percent for every degree C off of standard test condition that you change. So if you go up in temperature, your voltage will decrease. And as you go down in temperature, your voltage will increase. So I know that's a kind of a long, weird, winded way of saying, yeah, design is hard. You have to know what you're doing. But really, it comes down to 3 things. What is the roof shape? How many modules are you going to put on it? What is the voltage? Ostensibly, that's what we're trying to get. What is the voltage? And then what is the power classification? Like how much power are you putting into this one inverter? And that will kind of guide all of your system design. Like you can use those 3 principles to select a string inverter, to select a microinverter, or a SolarEdge optimized inverter. You can use those 3 principles for any of those things.
Nice. Let's see here. Got some questions about SolarEdge systems that we'll kind of save until we actually get to SolarEdge systems. Yeah, I know that one of our friends recently did a documentary on like early solar systems because somebody was really excited about like hearing about like older systems design.
Yeah.
You mentioned a documentary
Yeah.
that was done about
My good friend Jeff Stees, his company is Planet Planset, and he made a documentary on early homesteaders and how the solar industry was founded and really started. And I think in his documentary, he made claim that it was early homesteaders in California that needed to listen to their Grateful Dead CDs while they were home after they got home from work. So they would drive their Volkswagen bus from wherever to their home that has no power, no water, and they pull the 12-volt battery out of their vehicle and then power some small electronics with it. And even then, back then, you could get like cigarette outlet 12 volt power adapters for your wall, like in early like Homestead magazine. You could buy these kind of parts and pieces. I think you can still get stuff like that for maybe a camper van or even your own vehicle, but we don't see too much 12 volt batteries outside of the auto industry, I should say, anymore.
Right.
Mostly it's high voltage batteries that we were seeing. So yeah, I'll try to find a link to
Hmm.
it, and we'll drop it into maybe the description or send it out because it's a
Yeah.
fun video and everyone should watch it and understand. Yeah, we're jamming to Pink Floyd and Grateful Dead and just trying
Yeah.
to listen to some fun stuff while we're unwinding from work.
No, definitely. I saw a trailer for it, but I
Hmm.
didn't see the full documentary yet. So yeah, that'd be great.
Yeah.
Man,
And if we
I
don't
think
end up
it came out a
posting it,
couple years ago. Sorry.
okay.
Uh,
If we don't end up finding the link or posting about it, just email nightmode@solaredge.com, and we'll be happy to go digging for it and look it up. I'm actually really interested to see it because one of the old timers I started working in the solar industry with was their like boots on the ground, San Juan Ridge, mother truckers, when they were like importing a whole bunch of solar equipment from Germany and Europe to install on these homesteads. So that's actually really, really
that's
cool.
cool.
Yeah, so
We were
back
talking
then
about
it was
some,
it was all man, I think the earliest inverters I installed were like square waveforms, and they were just like banging voltage up and down, like on this nasty grid setting to make AC with it. And like I guess before the home setters was all DC, it was all 12 volts DC, and so our old Arco panels at like 40 watts is how we did that.
so I know one of the big design rules that has changed with a lot of these string inverters is that if you have multiple panels on the same PowerPoint tracker, they all still have to be in that same orientation. But that's a big improvement over you had to have every single panel in the entire solar array facing the same direction, usually on like a ground mount. It does give you a little bit
Yeah.
of design flexibility, right?
Yeah, so we use this word MPPT. Thank you, Chris. It stands for Maximum PowerPoint Tracker. And basically, it's just an algorithm that the inverter runs to determine what the most ideal power is, given your voltage and your current. So it'll scan the IV curve, and it looks like a little knee bend, and it'll find whatever the most ideal power output is. So when you have all these modules connected to a single MPPT, they all have to be facing the same direction. If you have an extra module on like one string versus two strings, that extra module is not going to do anything because yes, you increase the voltage, but the current has to stay constant. And so because the current is constant, the module just kind of drops out and is effectively useless. So that's why when Enphase started, like they're a microinverter company, right? When Enphase started, they were solving a big problem that the solar industry had, which was shade. When shade covers your array, your voltage and your current, well, your current really starts to drop because you're taking sunlight away from your solar panels. And so when your current drops, it kills the entire string. We call it the Christmas tree or Christmas light effect, where if one bulb goes down, they all go down. And that was absolutely the case for early modules. Now they have bypass diodes and it's less impactful, but it still has a huge impact. So when one module gets shaded, that's what microinverters was solving. Was like the drop in current kills a lot of the power on the string, and so they're going to put an inverter per every single solar panel. So old school string inverters like Tesla Powerwall 3 today has 6 MPPTs,
Mm-hmm.
and I mean that's still the same idea. Is like if you're going to parallel any of those MPPTs, which is what I think they recommend when you get to 4 strings, is you start paralleling MPPTs. You have to make sure all of those modules are facing the same direction and they're at the same tilt. Otherwise, you're only going to be able to produce as much power as the lowest producing module.
Wow. And that does bring us into module level electronics. And
Yeah, that's a nice dovetail.
mhm, yeah, and that brings us up to like the next evolution, which is microinverters. And you mentioned putting like tiny little inverters under every single panel, which gives you
Yeah.
a lot more design flexibility, but there's some other constraints that you have to worry about when you're designing a system with those too, right?
Right. So we talked early on, we talked about power and how much power you can put on your roof, right? Or how much power you're putting on your inverter, really. And so when we look at a microinverter, it's limited by voltage, current, and power. And so there's a thing that we call a DC to AC ratio, and that is the amount of DC power to your inverter's AC power. Let's use a 10,000 watt or 10 kilowatt inverter. If you put 100 and if you put 12,000 kilowatts, or sorry, 12 kilowatts, 12,000 watts on a 10 kilowatt inverter, your DC to AC ratio is 120%. Now that's usually typical these days because we know what standard test condition is, and we know when a module gets out into the field, it's not going to produce as much as the nameplate. It's never going to produce as much as it says it's going to produce. It's usually about 80% of that value. So microinverters really have taken advantage of that, but they haven't been able to scale up to match module power. And you think of the modules today, they're like 400, 450 watts. I see those going in very consistently in the last year. And your biggest microinverter is like 300 watts, 350 watts. And so you're really overpowering your microinverter, and you have a really high DC to AC ratio, and that causes a phenomenon that we call clipping. And so what is clipping? Basically, you overpower your inverter to the point where it cannot produce any more energy. And so if you have a 450 watt module, let's say it's a beautiful day and you're going to get all 450 watts out of that module, it's only ever going to produce whatever the maximum of that microinverter is. And so let's say you had a 300 watt micro, it's only ever going to produce 300 watts. And so I think we did a video on that when we talked about like beer in a glass and micro clipping.
Oh, the worst analogy ever that we did
The
during night
worst.
mode.
I don't know. I
We're gonna
got called
workshop
out
that.
on
We're
my
gonna make
act.
it work.
What was this analogy?
So
Well,
the analogy was pouring a very big beer into a regular glass
Oh, yeah. Okay.
versus pouring like a couple of beers into a very large beer stein.
Uh,
So it's with a single inverter that has a bigger capacity, you can pour more beers into it and not have to worry about it spilling over. Whereas if you've got a smaller glass and you pour a bigger beer into it, it's going to spill over.
yeah.
And we're going to make it work. One of these days, we're going to
Yeah.
make that analogy work. Doggone it, I'm sure.
Well, I mean, it's important, to
Yeah.
get these analogies across because, there's an application for it, right?
Yeah.
But, sometimes when you have a small footprint, and you have large modules, then maybe microinverters aren't the right decision, right? Because
yeah,
you need more power. You need to maximize all the juice or squeeze all the juice out, right?
Mhm.
There's another
exactly.
analogy, but
Mhm.
yeah.
Exactly. So you know what we should do? We should like make a little diorama, make a little popsicle stick diorama, and try to make this analogy work in real life.
Yes, there we go.
Sadly, sans the beer, I think an elementary school child could probably do a better job with the analogy than we did previously.
It's on the fly.
It's fine. It's fine.
Okay, so um, Steph says, I want a beer check. How do your beers taste? So, Cam, I'm going to
Uh,
let you go first.
like I said, I've had this beer before. It is delicious. It feels like I'm drinking a nice cream soda, IBC cream soda. It's fantastic. I love this beer. It's not light. It's refreshing. It's smooth. It is everything you want when you're in a beautiful 70-degree weather day in California.
Lovely. You just painted a really nice picture there. I'm really starting to get thirsty. Um,
You
so,
enjoy your bar of soap.
yeah, this one is definitely soapy. It's really good cold. But it's really heavy too, so I'm
Mhm.
afraid that when it warms up, it's not going to be so great. I'm gonna have to finish that sooner than later. How's yours, Chris?
Mine is doing pretty good. It's like if a lager and a really light sweet sake had a love child.
Oh,
It's good. It's really
cool.
it. I want to pick up more of this before I go home.
Nice.
This is actually quite refreshing.
So is it like a sake bomb? Is it a sake
You know
bomb?
what? That's pretty close. Like a very sweet sake bomb, but very mild. Yeah.
That's awesome. Kind of jealous now.
Let's see here. Got a couple questions. Micros. Also, while your east-facing microinverters are clipping, your underutilizing west-facing microinverters can't really do anything to help.
That's
so
true.
your underutilized west-facing microinverters really can't do much to help on those.
Yeah, I think that's our micro clipping argument. When you have a east-west array, and you have like the morning sun is coming in on the east, right? Those microinverters are like full power, full blast, and you have all this clipping. All this power is just spilling out onto the rooftop, not going anywhere, and not being converted to any usable energy. And your west-facing micros are just underperforming, not doing anything at all, really, because the sun is not shining on them at all. And so you have to wait till like 10 o'clock before those west-facing micros start working. And then conversely, when the sun is setting and you want all of that energy, you want as much energy as you can get if you're in a time of use market. So ideal orientation to face solar panels is the south for overall energy harvest. But I would argue that in time of use markets, when you face your modules west, you're producing the most amount of energy during the most expensive time of day for energy. And so it's the most economical advantage to placing modules on the west face. So when the sun is setting, those east modules, they're not doing anything for you. So micro clipping is pretty bad. Luckily with SolarEdge, when you have those east facing and even a multi MPPT string inverter, and you have those east facing modules, they're at least producing something. I mean, it may not be a lot, but they're producing something. So that is, and you have those west-facing modules with a large inverter. You're not experiencing that micro clipping at all, or maybe if you have microinverters, you are experiencing that micro clipping, and that's just a terrible thing to do on a day-to-day basis. A lot of revenue lost. Good call.
Here's an interesting question. Since we're going to be moving into SolarEdge inverters anyway. What prevents SolarEdge inverters from sharing a single battery bank instead of each one having its own battery? Is that something that is on the roadmap for the next gen system?
Let me try to dissect that question a little bit. We're a DC couple technology, and you want to share a battery across multiple inverters?
I think that would be the question. Yeah, I can see a use case for, like, I want to have multiple inverters and backup, but I only have one battery, so I just need them to come up and to have power so that they can power my house, and if a cloud goes by, they can still operate. But I can see there being a limitation in that being the amount of power that's in the battery as far as like watt hours, or kilowatt hours, because you drain that battery very, very quickly as soon as that sun goes down. If you've got two inverters, it'd be the same. Like if you had two 5K inverters, you might as well just have a 10K inverter, because you're just going to, that's the equivalent of power.
Yeah, it kind of sounds like, explain the difference between power and capacity is important here, right?
Yeah.
The more batteries you have, the more capacity you have, the longer you can withstand an outage. But the more inverters you have offers you more power, right? Is that right, Cam?
Sure. Yeah. So good news is we already do that. It's called AC coupling. And if you're AC coupling to a SolarEdge inverter, we can do that. And so if you have just a single battery with maybe an old home wave PV only inverter, we can do that. Or if you have a really old inverter like the old A series inverters, trade that thing in on the what do you call it? The trade-in program.
Re-energize program.
Yeah, re-energize. Trade that in on re-energize and get yourself a battery-enabled inverter. What I see most commonly, so it's a great question, and I wish I had read who said it. The most common thing that I see for batteries is I want more battery power. Like I already have plenty of solar, but I want more battery power. So when I go into backup, I want to be able to protect my largest asset, which is my home. So that's what I see. So I very rarely get questions about how do I share battery power from one inverter to the next. And wink, wink, nod, nod. We're kind of working on a solution for that right now. But today, if you want to do AC coupling, we can do that. And so you can AC charge that battery if you needed to. Not a big deal. You can do it.
Yeah, and currently our batteries balanced, right? So they charge and discharge together.
Yeah, if they're
So
on the
it's almost
same
like
DC
having,
bus, that's right. Yeah,
yeah.
yeah. So
I hear
easy,
you guys
done.
reading comments and questions I don't hear in the comment section here. Where are these people writing in? So if you're just joining Night Mode on YouTube recently, we've been doing this since 2024 on GoToWebinar. We're going to be moving over to YouTube exclusively, but we're currently taking questions on both platforms right now. So I've got two screens up right here, and I'm seeing questions coming in both locations. So I'm trying to take questions on both sides.
Yeah,
Rohit.
and it's the
Okay.
I think YouTube also has like that little delay. So if we do
Yeah.
ask a question on YouTube or respond, it's got a little bit of a delay on it. So just be mindful of that.
Yeah. We're also taking questions at nightmode@solaredge.com if you don't want to comment publicly and you just wanted to email us directly. Rohit, in NEM3 situation, battery can drain fast to grid for those top rate hours if one battery can be connected to multiple inverters. Oh yeah, it would drain that battery very, very fast. Yep.
Yeah, so most often you're limited to the battery C rate, which is the C rate is the battery's ability to charge and discharge. We call that a C rate. Our battery is a C over 2, which means it can charge and discharge itself in roughly 2 hours. So it's like a 10 kilowatt hour battery, and we can charge. It's a 10 kilowatt hour battery, and we can charge at 5 kilowatts and discharge at 5 kilowatts. So just because it was connected to two inverters doesn't mean it can discharge at more than 5 kilowatts. So yes, in theory, having a battery connected to multiple inverters would give you more power output. That is true. Let's say there's solar on each one, and maybe you're at 50% capacity on each inverter, and then you want to split that capacity of that battery to be able to discharge. You could do that, but what's going to happen in practice is that battery is going to dump energy. Uh, it's going to dump all available energy that it can. Yeah, I see what you're getting at, Rohit. That's a great question. So, good news is again, we're working on a solution for that.
Yeah, 10 or even 20 kilowatt hours sounds like a lot when you see that big box on the wall or multiple boxes on the wall. But in practice, it's not really that much, especially when taken into consideration like the difference between that and the power density of, say, your EV vehicle that's in your garage.
Yeah.
That's a massive battery as well. Yeah.
And I think these guys are looking at my roadmap because Jacoby is like, wouldn't it be cool if they shared the DC bus? That would be cool. Could you imagine if we shared a DC bus with an EV too? Like,
Yes.
Mel wants to know, what are those boxes beside you, Chris?
oh yeah.
The reason that we're in Milpitas this week, Evan and I, is because we're working on training content for the little box that you see over on the far side of your screen.
Yeah.
That is the SolarEdge One Manager.
Yep. Which essentially is a site manager or a site controller, right? So it replaces the CCG and also energy, so comms, right, for a commercial site. So this thing, you can land you up to a couple. You can land meters on it. You can land your CTs there.
A couple of meters, CTs,
Sensors,
right?
like
Yeah,
MET
and
sensors.
eventually it'll be able to control storage and EV, right? Coming soon.
Yep.
But
And
yeah,
they're digital sensors, right? No longer analog.
yeah,
Yep,
that's right.
that is correct.
Yeah.
So you may need to get upgraded sensors, but you can find them over at RA Plus, because I know the guy with the booth that has those sensors is always there.
Yeah.
And they're always the same sensors. So yeah, it's actually a very, very cool product. For those of you that are familiar with the old CCG that we've had around for years, it's been in the works for quite a long time because the firmware capabilities of that old system were fairly limited. So we needed to introduce a lot of different features, and so that means a new platform.
Yeah. And speaking of platforms,
Hmm.
the SolarEdge One platform is now available, and training's out there. So if you're in the commercial space, it's great. I've been working on the training, so
Hmm.
please check it out.
If the lights go out, it's because the motion. We've
Yeah,
reached the time of
I'll
day where
go
the motion
wake him up.
sensors are turning on so that it can save power. So we occasionally have to go wave our arms because we are after hours now, and so the lights try to turn themselves off as much as possible. Just tap the two buttons on the top
Got
right
it.
there. There you go. All right. One of the joys of not being in our studio is we can't control all the things.
Yeah.
That just
But
means we're
the
energy
other box
conscious.
right here, Cam, you want to tell us about that?
Yeah, that's my baby. That's I recognize it through here. That is the SolarEdge Nexus. The Nexus inverter with the Nexus Link, and it looks like 3 Nexus battery blocks. That is a modular approach to batteries, capacity, increasing inverters. Our next generation home battery and inverter product. It's been the last, I don't know, 2 years of my life working on that thing, and I'm excited because we've started alpha testing. We are going to get into beta testing soon, and it's it's going well. It's a good looking product, and I'm proud of it.
Yeah,
Yeah.
yeah, Cam, I've got to say it is beautiful,
Hmm.
and I'm excited for it. I'm putting a system in my house so I can test it. So,
Oh,
uh,
good.
very excited.
So you just started designing a system over at your place, right?
Yeah,
So you designed multiple systems, though, right?
yeah, it's kind of unique. I live
Hmm.
in a quadruplex,
Hmm.
and 3 of the 4 units wanted to get solar. So I'm putting solar on 3 units,
Hmm.
and
That's
so
cool.
it's like 3 systems in one on one roof. So
That's
it's pretty.
interesting.
It's
So
going well.
Yeah.
I've got my racking in. I've got my conduit. I've run wires. So next up is optimizers, modules, and then inverters. So
Cool. And what tools did you use? Did you go paper and pencil? Did you go software? What did you do?
yeah, first did a little paper and pencil.
Hmm.
Make sure the numbers kind of pencil out for the price of
Hmm.
of everything. I Solar Edge is going to help me with testing an inverter, right? But
Yeah.
everything else is on us. But after that, I went to Solar's Designer, and it was great. It's easy, it's free, obviously, but I was able to map out the whole site and then duplicate it, 3 times, and then create each site independently. And then I could just remove the extra stuff from the original site. So it's really flexible in that way.
Yeah.
And it's nice too because I was able to map where I want the conduit runs and essentially make a better estimated calculation of how much wire I'm going to need.
Hmm.
So yeah, I go to a lot of sites, or I've been to a lot of sites fixing stuff, but I haven't been installing stuff from scratch so much. So this is it's really great, really helpful for that. So
a new feature in the design tool is also your AC point of interconnection, and we now do AC conduit run as well. So if you put, like, you can identify where your meter is, now you can
mm,
put your AC cable length, and it'll spit out, oh, you need 200 feet of AC cable.
nice. I didn't see that. Yeah, that's great.
So the designer, like, shameless plug, designer, I think, is hands down one of the best tools available on the market. Uh, Especially at the price point. Like, it is, if
With a price
Yeah,
point, I can't beat it.
it is
yeah,
free 99. And I've been trying to workshop some ideas on how to engage homeowners more regularly with the design tool. And so
Yeah.
if you have any ideas, drop them into the comments, email us at night mode. And I I've been brainstorming some ideas, and this is where I'm at. When I bought a car recently, I really liked going online and picking out my car and then having it built for me and then having it delivered to my house. I felt that I knew what the price was. There was no sitting down and haggling with somebody. There was no reviewing a contract and saying, "Oh, what is the nitrogen fee? What is this $3,000 sales fee?" Like nitpicking all those little line items. It was much more, felt much more empowering sales. for buying a car, and I see that kind of that new format happening not in just auto sales, but in many other avenues of life today. And I'm trying to figure out like when you're a homeowner and you want to figure out how much solar to put on your house and like where to get started. Uh,
Hmm.
I'd imagine like there's a lot of people that are probably looking for like a design tool so they can get an idea or general recommendation of what they should put on their house. And so if we think it would be valuable, or if you're a homeowner, you think it would be valuable to have a tool that you could just log into, put some solar on your house, see what the kind of the general price is, so you can get a good idea of what to look for before you talk to a person. Like, let me know, and I'll try to create some content, some designer content, so you can learn how to use the tool. I think today, with as popular as 3D printers are, I think modeling is going to get much easier. There's enough tech savvy people that understand what a SketchUp is or how to use some type of 3D modeling that they can actually model a pretty good system. Blue Streak says it'd be helpful to them.
Blue Streak, yep. Right now, the barrier to entry as far as designer goes is the only thing you really need is an installer account. And you can create an installer account at monitoring.solaredge.com. It will require that you enter a serial number of an inverter if you want to have access to the monitoring platform and some other tools. But for a limited account, you don't have to enter in a serial number of an inverter. So if you just wanted to play around with it, try it out. That is one way that you could do it. If you
Yeah.
do have an interest in it, night mode at solaredge.com. More than happy to chat with you about it and hear your insights and see what your experience is like. You can find videos on the YouTube channel. There's a whole playlist around Designer if you just want to see what it looks like on the inside. Cam did a great job going through and just modeling a system with batteries and doing that work. Rahit wants to know, what is the best way to wire 3 inverters to a buoy when the utility requires separate production meter and disconnect for the whole home backup situation?
Yeah, sure. The easiest way is to combine those 3 inverters into an AC combiner panel, and then you're going to go through the production meter, the utility production meter, and then you have 2 options. Option one is you land in an oversized backup panel, simulating a Hawaiian tie-in. And what that would be like is, let's imagine there are 3 10 kilowatt inverters in your backup panel. You buy a customized 300 amp backup panel with a 300 amp bus, but you put a 200 amp breaker on it. So now you can put 160 amps of backfeeding breakers into that panel, and you can do it that way. The other option is to do a feed through panel. So that is where you go from the main service panel to the backup interface to an additional 200 amp feed through panel. And so you land your backfeeding inverters on this feed through panel, and then you feed the existing or a new backup panel. That's option B. And then option C would be PCS, busbar current management. So 3 inverters land directly into your backup panel, and that is the panel that you need to protect. And you protect it with busbar current management and enable PCS. So those are the 3 options, or 4 options, I guess, that you could do for combining 3 inverter outputs onto a backup system.
Nice.
And then, moving forward, again, we're addressing that in our next generation of backup interface that's going to go with the Nexus.
Nice. Yeah, and I know this isn't on topic, but I love the PCS and the PCS meters that we have out now, especially coming from the support side and training, because not only can you like extend and shorten CTs now because of the recalibration feature, but now you can flip CTs remotely via SolarEdge Go, and nobody seems to know this, and I'm like, hey, come on, like this is awesome.
I have qualms with it because one should always fix the wiring, but I can understand, like, if I can't get out to site for 2 weeks because I've got all this other stuff going on, at least I'm getting good data for that.
Yeah.
But
yeah, and
the stickler in me, like the small wire person, always wants the wires going right where they go.
Yeah, of course. Yeah, you need to test it before you leave the site.
Yeah.
Of course. But yeah, reality is
Designer works great. My only annoyance is that I can only put 3 batteries on 3 inverters.
That is true.
Yep.
One battery per inverter. Is that what that
No,
is?
I think he's saying 3 inverters. The designer is limited to how many inverters you can do in backup. So if you were doing a multifamily dwelling and you wanted to design with, let's say, 10 inverters, you can only put batteries on 3 of them. So that is a known bug that I'm trying to get resolved. And
Yeah,
we're
and
basically,
MDUs are. Go
yeah,
ahead.
yeah, we're trying to get that just basically tied to the backup toggle. Um, yes, I'm trying to get that tied to the backup toggle, but now I'm thinking that might not be the best solution. So,
Yeah, MDUs
okay.
are definitely becoming a big part of the market right now, for sure. I know several of the big players are very invested in big systems, multiple batteries, lots and lots of batteries, lots of inverters on multiple dwelling units.
It might be easier to add a button for backup interfaces, like how many backup interfaces are you going to use, and only limit it to 3 inverters to per backup interface.
I will make a note to
Right.
try that out after we're done.
Yeah. Oh, I've tried it out many times. I know it's a problem.
Oh, okay. Let's see
Every time I
here.
think I have a fix, it's not fixed, and I'm working with my product team in Israel to get that solution fixed. You're right.
Jake wants to know what's the biggest system you can design for backup.
So it's going to be 3 inverters with 3 batteries, so 90 kilowatt hours of energy storage with 33 point. Actually, now I think we're doing 12.5 kilowatts in backup. So now you're
12.5.
30.
Yeah.
Oh no, but you're still. It's only 12.5 kilowatts if you have a single inverter. If you have multiple inverters, it's still 11.4. So yeah, it's still what is that? 34.2. Yeah, 34.2 kilowatts AC in backup. But the LRA is substantial with that. We offer 101 amps of LRA, 101 or 106, 106 amps of LRA per
106.
inverter. And I wonder,
Let's see here. Mike wants to know, you mentioned DC to AC ratio. Uh, you do 200% DC to AC ratio. What are the limitations on that? I would say that the limitation on that would be
well,
it
technically
doesn't
now
make
it's like
sense to have
200.
200% DC to AC ratio if you don't have batteries. Because Cameron talked about clipping earlier, and you still experience clipping with larger inverters. So if you've got an 11.4 inverter, your inverter under normal conditions is still only going to produce 11.4 kilowatts. So if you oversize your system to 22 kilowatts up on the roof, you could potentially be leaving a lot of power up on the roof. Typically, I find the point of diminishing returns is probably around 135 to 150%. Most installers I know will oversize to about 120% because STC rating, it's that standard test conditions, is not real world conditions, and you can only expect
Right.
about 70 to 80% of what the STC rating is in real life. So absolutely, you should be oversizing, but the point of having that oversizing is so that you can take all of that extra DC energy, and because you have a DC coupled battery, you just take all that extra energy that would normally be clipped and you just shunt it right into your battery. So you're producing as much as you can with your inverter and you're charging your battery all at once. And Cam, you can
Yep.
probably give us other benefits as well.
Yeah. Just like you said, uh,
Yeah.
200% DC to AC ratio is a capability, not a general good idea or guidelines. So absolutely, if you're going 200% DC to AC ratio, it's usually coming from when you're doing that much oversizing. It's usually as a result of a utility requirement, like export limitation, and maybe the utility will say, I don't want this system to be larger than 5 kilowatts because of the transformer size. But again, those types of complaints or dilemmas are going away with PCS. So with PCS, you can say, okay, I'm still going to use this 11.4 kilowatt inverter. It will never export, and it's certified, PCS certified, to export no more than 5 kilowatts. And so now your system exports 5 kilowatts. You don't have to upsize the transformer. The homeowner gets to utilize the full capability of the inverter. And just as you said, any energy that is not being exported is charging the battery, or any energy that's being clipped is charging the battery, just because we're DC coupled. Yep.
Yeah. And I've had. Is he? I think he's still talking.
Yep, you're good.
I see his waving his hands there.
You're good. Go ahead.
Well, anyways, Cameron, I had a question for you about that because, even if it is clipping, is it always terrible? Because wouldn't you have higher shoulders in the morning and then the afternoons that have more production?
Sure. There's a point of return on the shoulders. And so yeah, you're right. If we look at a power curve, it looks like a bell curve, a good distribution curve. And when you clip, just imagine you're taking off the top of my head, the bell curve. And that's this portion is the amount of energy that's lost. Okay, great. That's what clipping is. And so the idea is, like, when you have this bell curve and you just raise the shoulders, and even though you're clipping here, you have more energy down here, right? And so that's what raising the shoulders is. So you have more energy throughout the year, but there is definitely a point at which you're clipping so much that you're losing more energy at the top here than you are raising the shoulders. And so in general, I think most designers will design between 125 to 135% DC to AC ratio. I think that's well within reason. It might clip 1 to 2% in year one, and then by year 5, you're not clipping at all because of photo degradation. But if you're designing to 200%, then you're clipping a substantial amount of energy year over year, and you may always clip, like even at year 10 with that high DC to AC ratio, you're still probably going to be clipping. And so it's raising the shoulders definitely gives you more energy, but there's definitely a point of losing energy. And those modules are expensive. I mean, especially with tariffs, modules coming in now, they're all U.S. made. Hopefully, we're all buying U.S. made modules, domestic content modules. And yeah, they're starting to get expensive again. So there was a point when modules were like super cheap and maybe 60 cents a watt and 40 cents a watt, and you could get them. Yeah, it didn't matter, but now it's going to start mattering.
Yeah. Well, on my neighbor's roof, we don't have, or my roof and my neighbor's roof, since we share a roof, we don't have much real estate there. So we're putting in 3,800 watt inverters. And since they don't have batteries, I think you can oversize a hub inverter to 155%.
Yep.
Right?
Yep.
Pretty sure.
200%.
The home wave.
Without a battery, right? So they don't have batteries.
No. You should go 200 without a battery on home hub. Yep.
Oh, okay, great. Well, I planned for 155, and I was using the designer. And after I put everything in, it was 156. So I took a module back and put it into my system. So now my system's oversized at like 186% with batteries. So
that's funny. Yeah.
That's perfect. Yeah.
I think it's great. Yeah, I'm excited.
I've done 8 inverters with 6 batteries for non-backup systems and 3 inverters with 6 batteries for a backup site. I love it when a customer wants a maxed out system. That is 100% true. And when you're doing time of use arbitrage, those big battery systems are just 100% absolutely essential. California, we've got NEM3 systems where you're not getting paid back nearly anything from the utility unless it's in like a very specific time of year. So having batteries to avoid those peak rates is absolutely necessary for you to get any type of ROI for your customers. So I think Cam was doing some calculations. You got a 6-year, or you actually had a better return on investment when you added a battery to a system you were designing just for chuckles, and you added a battery and you got a quicker return on investment?
Yeah, absolutely. So if you design a PV only system with today's prices, your return on investment is usually 10.1 years. And when you get beyond the 10-year mark, like, most homeowners are not going to keep their house for 10 years. Actually, that might be changing today too, because I don't know of anyone trying to get out of their home. They're trying to keep their homes, right? So maybe it's a tougher pill to swallow when your return on investment is 10 years from now, right? So the golden mark is usually like 6 years is like, yes, sign me up right now. And then 7 to 8 years is a little tougher, but still doable. And so, yeah, you can design in California, you can design a PV only system and the payback may be 10 years, 12 years. And you add a battery to it. If you export your battery to the grid, then you're going to get a 6 year, 7 year, 8 year payback for your battery. Like it depends on a couple things. One is your consumption profile. So that's how much energy you're using on a year to year basis, and then when you use that energy. And so there's this thing that most utilities subscribe to called green button data. And if your utility, like log into your utility account and you can download your green button data. What that means is the utility will give you your energy usage for every hour of the year. And so you can look from January 1 to December 31st, how much energy you're using every hour. And in the SolarEdge design tool, you can upload that data and you can say, yep, here's my yearly usage. And now I know that in the month of August and September, when my power hours are, I'm generally conservative. And so I'm going to get a lot of return on investment because I'm exporting all this energy to the utility company. Or you could say, oh, I don't change my habits at all. I come home and plug in my EV and turn on all my lights and start throwing disco rave parties in my house, whatever it might be. And so you're not getting any return on investment because your battery is discharging, but it's only offsetting your home loads. It's not exporting to the grid. And so in California, exporting to the grid is basically value less unless it is during 2 hours of the day for the month of August and September. All other times, you don't want to discharge to the grid, which kind of sucks because every time I discharge to the grid or send energy to the utility company, I'm basically powering my neighbor's house. And it's, path of least resistance, right? So my electricity is going to my neighbor's house. It's not coming from the power plant that's installed in Arizona, right? And so it is beneficial that we all discharge to the grid, but I know why utilities are doing it, which sucks.
Yeah, of course.
It's called the duck curve.
Yeah, I know at least one person that has put load controllers on their heavy loads, like say an electric dryer,
Nice.
so that their significant other cannot use that load as soon as they go into peak rates. Like it automatically shuts off. So if that person wants to use the dryer, they can't.
Oh man.
Totally do that as soon as I get my system there.
That's funny. I might get calls like,
hey,
"Why isn't the dryer working?" And then I'll probably like forget I did that. I'm like, I don't know. Let's call the appliance repair guy.
Yeah. Right.
Eric with a K, love Eric with a K, wants to know, how does Designer compare to PVSys and Aurora?
That's a great question. So actually, I had a call with PVSys this week. PV Watts. I had a call with PV Watts and NREL this week. So PVSys is the gold standard in PV simulation is what I'm going to say, but their market segment is mostly commercial and utility scale. And when you are doing your D&V study on like how accurate is my design tool, which SolarEdge has a D&V study of how accurate our design tool is, we are within 1 to 2% of PVSys. So the best of the best of the industry, the banks and the insurance companies use, we're within 1 to 2% of what they say, which is exactly where we want to be, right? Aurora and Solo are fantastic tools. The benefit of those tools is you really get to model any inverter. And so you can say, I want to model SolarEdge today, or Tesla today, or Enphase today, or Franklin, or whatever it is. You can use that single tool for all of those products, right? And I think that's what a lot of incentive is for American designers. However, that comes at a cost. Those tools cost money. The SolarEdge Designer in itself, again, is free. You can go to SolarEdge.com, click on login. I think there's an option for Designer, and it'll walk you through how to create an account. And I believe for Designer, there's a checkbox that says, I don't want access to the monitoring portal. And so you can uncheck that box. So we removed the requirement for the serial number and stuff like that. So you can use Designer without actually having an inverter, which is, again, what we kind of want to help our homeowners use. But you can use Designer, and it is completely free. And again, I'm going to say it is a very competent design tool. And that gets me to PV Watts. Now, PV Watts is created by the National Renewable Energy Laboratory, so NREL. And NREL is funded by the Department of Energy, the DOE. Okay? So PV Watts SAM is a free open source simulation software that allows anybody to just put in some numbers and get a good idea of what they expect a PV system to produce. It's all physics-based simulation. Like, so there's no like guesswork. Like, it is all physics driven, and so it's all fairly accurate. The only problem with PV Watts and NREL today is they don't do the best job when it comes to module level power electronics and specifically optimizers. They do a good job. It's just not the best. It could be better. So that's why I had a call with them earlier this week. Like, how do we improve this? And the good news is they have some funding, which is, getting funding from the government for anything these days is next to impossible. So hats off to them. And so we're looking to assist them in improving their simulation. And so when you're doing PV simulation, again, it's all physics based. The more difficult part is battery dispatch. And that's no longer physics based. That's algorithmic based. And SolarEdge's dispatch algorithm for batteries in California is a little bit different than Enphase, a little bit different than Franklin or any of these other products. And so it is what I find with Aurora and with Solo is because batteries are so important to your payoff period that they need to do a better job of working with the vendor to see how their battery is going to discharge. And I think that's where kind of the fault with third-party design tools are. SolarEdge, we know how our battery works really well. I mean, we programmed the damn thing. We should know how it works really well, right? And so we can tell you exactly how it's going to dispatch during the California power hours, during demand time of use in Arizona. We can tell you how it's going to dispatch during these events, and we can give you a reliable estimate of your return on investment based on what your utility rates are and how much your products cost, etc. So I think that's where Aurora and Solo and those other third-party design tools need to catch up. Is I know why they're trying to stay brand agnostic, but I think they actually need to work more closely with the manufacturer and get the information directly from the manufacturer. That's my humble opinion.
And to speak well of Aurora, I know that they have been very open to talking with vendors about improving their modeling to make sure that everything is displayed properly. It's just a long process because they have to verify the information that's given to them by the manufacturer, and there's a bit of back and forth that goes with it. But I know you've worked extensively with Aurora, and we've got a great relationship with them to the point
absolutely.
where we've got design videos on our YouTube channel where we show how to design our systems using Aurora, which brings me up to a question Steph is asking. How do I show only US-made equipment on Aurora?
Great.
Yeah.
That's easy.
So we actually do have a video for that is on our YouTube channel. Steph, if you want to email nightmode@solaredge.com, I can point you to that directly. But short answer for that, Cam, is
all you have to do is go to, when you're in Aurora, log into Aurora. On the left-hand column, there's a section for your database. And so you go to your database, you go to inverters, and you search like SolarEdge, and then maybe in parentheses put USA. And anything that's got the USA moniker is domestic content. Now, I think it's important to note that domestic content is different than made in the USA. Yes, all domestic content products are made in the USA, but not all made in the USA products qualify for domestic content. SolarEdge, as a manufacturer, all of our products are domestic content. That means that a certain percentage of our equipment all the little discrete components, parts, and pieces are made in America. So we're getting capacitors that are made in America. We're putting them on the PCB that we are manufacturing in America, and then we're assembling all those PCBs into the inverter, which is also, made in America. So we're doing that out of our factory in Austin, Texas, and I've been to that factory. It's quite beautiful, and if you're ever in the area, reach out to a salesperson, and we can maybe get you on a tour. And then we manufacture our optimizers in Florida. So, and then also we announced we manufacture our batteries in Salt Lake City, in just a Provo outside of
Very
Utah.
excited about that.
We are manufacturing all of our equipment in the United States with components from the United States. So that is kind of a huge win for SolarEdge and the U.S. economy.
Yeah, I'm seeing a number of questions coming in about domestic content and how to calculate that. Honestly, we don't give tax advice. We can't do that. It's a very, very complicated field to go into. We do have some really, really good staff that speaks directly about that and can give you additional information.
I can break it down really easy.
SolarEdge.com. If you want some additional information, we'll be happy to relay your questions and get you some answers.
Yeah, so real easily, real simple. Domestic content tax incentives are only given to third-party owners. They are not for installers, and they are not for homeowners. They're for the third-party owner. So if you are a large installer and you're installing systems on a lot of people's houses and you own the asset that is on somebody else's house, then domestic content is meaningful to you. If you are not a third-party owner, then it is not meaningful to you.
And that's for residential.
Yeah, it's for residential.
And there's whole different rules for commercial as well.
Yeah.
It's an interesting time to be in the industry. That being said, we have reached the end of the hour. Usually we try to go for a half an hour, but there was a lot of questions that came in. Really, really enjoyed talking with all of you today. Again, next time we are going to be going exclusively on YouTube. So if you're used to looking for a go-to link, that's probably going to disappear, and just join us on the YouTube. You'll see me post the next episode coming up on the training portion of our website. And then you'll, of course, see it on our YouTube channel, and we'll blast it out on LinkedIn on the Monday or Tuesday before, just so you know. Really, really, really enjoyed having you here today. Next week, we were going to do, or not next week, but the August 7th episode, we were going to be doing a special episode on SolarEdge visiting Puerto Rico, because Cam just got back, and you've spent a lot of time in Puerto Rico as well.
Yep.
We are trying to arrange getting a industry guest with us, so we may have to switch that up with a different topic. But really, really excited to talk about Puerto Rico, because it's a great market to be in if you're in the area.
Absolutely.
Absolutely. I can't say enough good things about Puerto Rico. It's beautiful. The food is delicious. Got some mofongo when I was down there.
Nice.
Hope I said that right.
Yeah.
Yeah, there's a couple of YouTube shorts with Cam walking around just like surrounded by all this beautiful greenery out in Puerto Rico. It's on the YouTube short section of our YouTube channel. Just really, really cool. Excited to go out there myself one day. Not happy about humidity, but maybe I get to go out there in like December or January when it's nice. Yeah.
It's always humid.
Yeah,
It's always summer. It's great.
But again, we reached the end of the hour. So I just want to say thank you to everybody that came out. Thank you, Evan. Thank you, Cam. I'm Chris. This is Evan. That's Cam.
My name's Cameron.
Stay sunny.
Stay optimized.
Yeah.
Thanks,
All right,
guys.
folks. Bye. Oh, the computer's over there. I got to walk all the way over there to hit the button. Oh, no. Okay.
Wait.
Bye, guys. Love you all.
I can end it.
Have a great week. Okay, 39 people. Not bad. Oh,